Forgot. So when we're talking about today about multiplying terms, because remember, when you're talking algebra, then you're talking, what are they called? Terms, exactly. Because remember, in arithmetic, all you had to work with was numbers. But now we're working with terms, and it's really important that you understand that concept. It is the single biggest mistake that students make, is not understanding what a term is. Now, there are all kinds of terms. We're working with simple algebraic terms. And why do we call them algebraic?
Because they're made of algebra.
Well,
variable.
Right, because the variable, which is what makes things algebra. Yeah, you're on the right track, but got to be more specific. Okay, so algebraic terms, because they have variables in them, and we can use any letter or symbol to stand for a variable, right? Okay, so today we're going to talk first. I want you to tell me, or just review, the parts of an algebraic term. What is the first part of every term?
Sign.
It's sign. Excellent. Every algebraic term is either positive or negative. Which means that addition and subtraction change a little bit, and now addition and subtraction become combining because you're working with signs. Yes. So pardon me? Okay, well, number one is sign. So what's number two?
Coefficient.
The coefficient. Excellent. Thank you. Okay. And remember, does coefficient mean number?
No.
No. Coefficient means multiplier.
The little thingy on top of it.
Okay. But when you're talking about a simple algebraic term, that multiplier is always a what? A number. All right? So, okay. So, no, coefficient's not an index, but coefficient is the number in front. So, for example, if we have 4x, what is the coefficient?
The 4.
The 4, because they're multiplied together like that because they're side by side.
It's just x. There is no coefficient.
Yes,
Base.
the coefficient is the 4. Guys, all right, now, next, what's the third term? The base. Excellent. And for an algebraic term, the base is always simply the what?
Variable.
The variable or variables, because you can't have more than one letter in a term, yeah? Right? We can have an A-B term, can't we? Okay, excellent. And finally, the fourth part, whether you see it or not, is an exponent. Sorry, you're being so polite and raising your hand. Okay, but during this time, when we're just reviewing the notes, for y'all guys, just call out if you know it. That's fine. Okay?
Like me.
All right. Well, maybe not exactly like you, but all right. Exponent. Now, what if you don't see an exponent? Does anybody remember what exponent there is if you don't see one? It's a 1. Good. What if you don't see a coefficient number in front? What do you assume it to be? Also a 1, right? Remember that in most of mathematics, if you don't see something there, then you assume it to be a 1. What if you don't see a sign?
Multiplication.
What? No, I mean a sign. Remember the sign. So it's positive, right? So if you don't see a sign. So like this term, for example, doesn't have a sign, does it? So we assume that sign to be a positive. Okay? All right. So if you know the 4 parts of a term, then you can work with a term. You can do anything in algebra with these terms if you know the 4 parts and know what they do and how to deal with each one. And if you know them in order, then you know how to deal with them in order. Is order important in mathematics?
Yeah.
Absolutely. And so you need to really think about it. So let's go through the steps for working with it. So what we're going to do is go through the steps for multiplying terms. Now, it doesn't matter how many terms you have, what kind of terms they are, what signs or anything else. The rule for multiplying terms always stays the same. Now, your job, however, is to make sure you're talking about multiplication. So if I say 4x times 3x, Remember that 4x is right in front of that parentheses. Does that mean multiplication?
Yeah.
Yes. But what if I say 4x and then the 3x like this? Does that mean multiplication? No. So you've got to slow yourself down and pay close attention and always understand that the operation is the most important thing. So the first step in doing any mathematics is to ask yourself, what operation?
What comes next?
Because if you don't understand what operation, then you're not going to know how to use the order of operations, and you're not going to know what to do to each thing as you go. Does that make sense? Right? Okay.
Yes.
Do your classes change almost every week? Yeah. Okay. Do you always know exactly where to go?
No.
Sometimes you have to stop and think about it. Otherwise, you're not allowed just to go to any classroom you want to, are you? You've got to follow the schedule. So you see that sometimes that you have to think about the operation and make sure that you look through the problem. It's a big problem with mathematics. We just want to jump in and start doing things. And that's never a good plan. All right. So always think of what operation. Now, when you're multiplying terms, so I'm not even going to give that a step. I'm just going to say what operation, because that's just something you must do every time. Well, what is the first part of every term? The sign. So that's what you need to deal with first. Okay? So we're going to talk about the rules for multiplying and dividing with signs. And luckily for us, the rules for multiplication and division with signs are the same rule. Okay? To multiply or divide with signs. Now, yesterday, we looked at how to combine signs, right? If the signs were the same, we kept the sign and added the numbers together. If the signs were different, we kept the sign of the larger number and subtracted them, right? Because difference means subtract. Well, today we're going to look at the other two rules for working with signs, but they don't deal with combining, they deal with multiplication and division. Now, they look very similar. So you've got to make sure you know what operation you're using so you know what rule to use. The first one says that if the signs are the same, meaning they're both negative or what? Both positive. Good. Then the answer is always positive. It doesn't matter if they're both negative to start with or they're both positive to start with. If the signs are the same, then the answer is always a positive.
There's my notes. I have a special note.
All right. Now, this is where that saying comes from that two negatives make a positive. I do not want to hear that saying because it's not true. A negative times another negative makes a positive. A negative divided by another negative makes a positive. But two negatives never make a positive. That's just not a rule. You have to have the operation. No, that's just not it's a nothing. It's a made up thing. It's not real. Okay?
So what do two negative things?
It depends on the operation. Okay, now, the other rule says that if the signs are different, what does it mean if they're different?
One's positive and one's negative.
Exactly, one of them's positive and one is negative, and it doesn't matter what order. Then the answer is always negative. Okay? So what if I'm multiplying and the signs are the same? The answer is
It's a
positive. What if I'm dividing and the signs are different?
It's negative.
It's negative. Okay? And we always want to get the signs done when? First. Exactly. It's the first part of the term. Should be the first thing you deal with. Because many times we know our sign rules, we just forget to write down the sign. Ever happen to you? Yeah, so it happens a lot. And especially later when you're doing more complex mathematics and there's a lot to do. Well, the sign rules are pretty easy, so we think, yeah, I'll remember that. And we don't. Okay? All right. Second step is to simply multiply the coefficients. Now, yesterday we talked about the idea of like terms, but that's only when you combine. But when you're multiplying, you can multiply anything together. So it doesn't matter. They don't have to be like terms. So just as long as it's multiplication, just take all the coefficients, and remember the coefficients of a term, it means the number parts, right? Just take all those numbers and multiply them together. Okay? Third, okay, we'll just keep all of the bases. Because we can multiply an A times a B. But if you multiply an A times a B, what do you get? AB, right? You can't really do the multiplication.
Because you don't know what they are.
Because we don't know what they are. But so all we do is just keep them. So what if I have an A times a B times a C?
ABC.
There you go. So you just keep the bases. They don't change. You just keep them. What does change, though, are the last part, which is the exponents. And now exponents mean to multiply, but they mean to multiply over and over and over. So what you're going to do is simply add the exponents. If you have any. Now, what if you don't see one? What do you assume it to be?
1.
A 1. So you do have stuff so you can add, okay? Okay. But we only add the exponents on like bases. So, for example, if I'm multiplying an x times an x, is an x times an x the same base?
Yeah.
Yes. So I have to add the exponents. Guys, all right? If I multiply an x times a y or an x and a y the same base, then I do not add the exponents. Do you see the case? Do you see what's happening? Right? Because they're not the same base, then the exponents won't change. Now, what if I multiply an a times an a? Do I change the do I add the exponents?
Yeah.
If it's an a times an a? Yes, because they're both the same, right? Get it?
Yeah.
All right. And we're going to look at lots of examples. And actually, Education Perfect is going to drag us through some things about exponents. And I'll show you exactly why that happens when we're doing those. Okay? So, first thing you do is determine the sign. Second thing you do is multiply the coefficients. Third thing you do is keep all the bases. Fourth thing you do is
Add the exponents.
well, on the like bases. So that's the same thing as a term, isn't it? You do the first thing, the second thing, the third thing, and the fourth thing. So if you know the parts of a term in order, then you know what to do in order. Okay? All right. So let's go to Education Perfect and look at and go through some exercises together. Now they're going to talk about what we just talked about, but they're going to talk about it in a slightly different way. I like to keep things consistent, right? But they're also going to talk about explain some things about why some of this works, and that's important, right? This is the process to how it works. But sometimes people have trouble just following directions if they can't see the why, right? So we're going to talk about the why as well. Now, what's more important, the how or the why?
The how.
The how, because you've got to do it, right? But it makes it more clear a lot of times if you see the how. Okay?
Then you can try and remember it.
So here we go. So, kia ora, and welcome to this lesson on simplifying multiplication and division, because multiplication and division are related operations. Okay? Now, first thing is, remember that in algebra, we write as little as possible, right? So I don't write A times B. What do I write?
AB.
AB, right? So then that's going to be a common theme as we go through all of these things in algebra, okay? So there's special rules that we use. So for example, just like I was saying, if you have 3 times A times B, instead of saying 3 times A times B, what would you say?
3AB.
3AB, right? Remember, though, that the only operation that works on is multiplication. It's the only operation that requires no symbol at all. All right, go. Come on. All right. So just 3AB. Good. Now, that does not work if it's not algebra. So 2 times 4 can't become 24, right?
So it has to be 8.
2 times 4 is 8. So don't try this with arithmetic. This only works with algebra, the variables. Okay? Good. We also talked a little bit before about writing those operations, how the operations change. Instead of writing the division symbol, you can write the division symbol using a fraction, the fraction bar. So W divided by 5 is just the same as W over 5. Right? Okay? Good. Now, this next screen may surprise you a little bit because you may not be used to it. But if you have 1/5 times W, if you remember that when we were doing the measurement ones, if you have multiply by 1/2, that's the same thing as simply saying divide it by 2. Right? Do you remember that? Or I could say 1/2 times W is just 1/2 what? W. Because, all right, look, let me show you this. Guys, look, watch, because it's not that big of a stretch. What would you write if you had 2 times W?
2W.
Well, 2W, right? Well, then, by that same logic, then, 1/2 times W is 1/2 W.
Oh.
Right? You can just put them together.
Oh.
Okay? But since it is a fraction, multiplying by a fraction is the same as doing division, isn't it? So multiplying by 1/2 is the same as dividing by 2.
2.
So 1/2 times W, W over 2, and 1/2 W are all identical. They mean exactly the same thing. And you're going to see them in the same way, in that format all the time.
Which
Okay?
one?
So do you see all of them? So do you see that the reason why they're the same? Multiplying by 1/2 is the same as dividing by what?
2.
2. So you could write it as W over 2. Multiplying by a number times a letter just puts them side by side. So you could also write it as 1/2 W. So what if I wanted to say 1/3 times W? How could I write that? 1/3 times W. 1/3 W. Yeah, I could just shove them side by side, couldn't I? But since it's a fraction, multiplying by 1/3 is the same as dividing by what number? 3. So I could also write it as what? W over 3. Do you see? These two things mean exactly the same thing. And sometimes it's easier to think of it as multiplication, so you have 1/3 W. Sometimes it's easier to think of it as division. You need to just be able to make the decision between which one, and you will based on experience. Okay? Excellent. All right, let's continue. So let's simplify this expression. Okay? So let's do this piece by piece. First of all,
Brackets.
we have to deal with the brackets first, don't we?
Yeah.
Okay? And inside this bracket, I have some multiplication and I have some addition. Which one do I need to do first? You bet. And the multiplication is 4 times x.
4x.
So 4 times x just gives me 4x. Excellent. And then I have plus 3. Can I add 4x and 3?
No. But
No,
that's
because they are
4.
not, hold on, because they are not, what are they called? Like terms. Good. Then I have this thing, this 2 times y,
2y.
which is just going to give me 2y. Okay? But what is between those two brackets? And the
Divide.
easiest way to write division is what?
Fraction bar.
As a fraction bar. So the simplest form comes out to be 4x plus 3 over 2y.
I've got a question.
Yes.
Why can't we say 7x?
Because they're not like terms. This
Four
is an
and
x.
three are.
No, this is an x term, and that's a number term.
Oh, I see. Yeah.
So they're not like terms. Okay? Good. Excellent. You're going to get lots of practice doing those as you go. So there you see they're working. Show. All right? Good. Let's see what else the next thing is. So next we want us to talk just about simplifying multiplication. Now remember, sign, multiply the coefficient, keep the bases, add the exponents, right? Okay. So if we're going to do this particular problem with 3t times 4w, first of all, the only operation up there is multiplication. I can multiply anything together, right?
Yeah.
Okay. So the sign, positive times another positive, is still a positive.
Positive.
Right? 3 times 4 is 12. And t times w is just tw. You're done.
Is the plus in front
Now,
crucial?
No. Do you have to have the plus?
No.
Would I count it wrong?
No, because
Some other teachers might in the future?
But it's still
yes.
positive.
So, you don't have to have the plus, but I don't mind if you put it. Okay? Now, I want to show you how they work this out and they explain it. What they do is they group the numbers together. Do you see this? They group the numbers together, then they group the variables together. And that's fine, and it shows you what's happening, but is that really the way you're going to use it? Are you going to rewrite it all like that? No. Just do the signs, multiply the numbers, and then combine the variables. Put the variables side by side. Okay? So, you're going to see their explanations, and their explanations make sense, but they're really more talking about the why than the how. Okay? All right. Remember, algebra is all about doing things as simply as possible. So you'll see there, and they get to the 12 TW just like we did. Okay?
Wait, Mr. South.
All right.
Can I ask a question? So you know how yesterday you were like, kids get worse at math here. Did you just get better here? Because you're a math teacher.
I'm not understanding. Well, let's focus on this, and then you can ask me that. Hold your question. Okay, here we go. First of all, what operation is indicated all the way across here?
Multiplication.
It's all multiplication, isn't it? So that means I can multiply all of those terms. How many terms do I have there? 3. That means I can multiply all 3 of them. So let's first determine the sign. What's the sign of the first term?
Minus.
So a negative times, the second one is a what?
Plot times.
And the third one is a positive. So a negative times a positive is a? Negative. Times another positive just stays negative. So you can do more than one sign as you go across. Okay? So we know that our answer is going to be a negative. Now let's multiply the numbers, guys. So 5 times 2 is 10. And 10 times 3 makes 30. And now all I need to do is put in all the letters. So I'm going to have a P and a Q and an R. They never change. You just stack them together. Now, P, Q, and R. I do have to look at it to make sure they're in what?
Order.
Alphabetical order. Are they?
A, B, C, D, E,
Yeah.
F, G.
P, Q, R is in alphabetical order.
J,
Right?
K,
Okay.
L.
Now, what if I had multiplied it and got 30 R, P, Q?
No.
I couldn't leave it like that. I would need to rearrange it to be in alphabetical order, right? So sometimes the letters, when you just stack them together, won't be in alphabetical order, but you need to make sure that you put them in the alphabetical order.
Why?
Because that's the algebraic convention,
Because
right?
algebra is
Okay.
like that.
All right. So then they just show you their working where they divided out all the numbers and then put all the letters together. And again, if you need to see it that way, that's fine, right? But at some point, you need to get more efficient. Okay. Now, let's talk a little bit about indexes. An index, in my I'm sorry, and I don't call them index. What's another word for index? Exponent. Or there's even another one, which is a power. So it doesn't matter what word you use, but a lot of times you're going to see index in your books or your instructions. So it's important that you understand all three of them. Remember that if you have four sets of 3, then that's the same as saying 4 times 3. That's where multiplication comes from. Multiplication just is the same as just saying repeated addition by the same number, right? So 2 times 5 really just means you have 5 2s added together, right? So multiplication is just a shortcut for addition with using the same numbers. Well, the shortcut for multiplication is using an index. Notice we have three threes all multiplied together here. Well, instead of saying 3 times 3 times 3 times 3, because they're the same number, I can simply write that as 3 to the 4th power. Okay? So what if I had 5 2s multiplied together? That would be 2 to the 5th power. All right? So exponents are just a way of making multiplication more efficient. Okay? Now, what if I have an x times a y? What's that give me? What's x times y? xy, right? Now, the no exponents change there. But look what happens on the second one. I have x times x times x times x times x, which is the same as how many x's multiplied together? 5 of them. So instead of writing 5 of them, I could simply write that as x to the 5th power. And the reason I'm going to get 5 is because I'm adding up all those exponents, but the exponent when you don't see one is a 1, right? So it's just 1 plus 1 plus 1 plus 1 plus 1.
Which is very hard because I lose count.
No. All right. So what does 2 to the 4th mean? 2 times 2 times 2 times 2, right?
2 times 2.
Okay.
That's a lot of 2. Times each other 4 times.
4 times. Excellent. What does sloth to the 3rd power mean?
3.
Sloth times sloth times sloth.
Sloth? Why are you?
Because that's what they gave me there. Okay?
That's mine.
All right.
Yeah.
What if you don't have an exponent? What do you assume it to be? 1. So anything to the 1st power is just equal to itself. Guys, you're getting off on the sloth there. Get them back. Come back. So what if you have g to the 2nd? What does that mean? G times G. Okay, good. Okay. All right. Now, the notation is what they give you next, and it's really easy. If you have some x to the n, that's just called general notation, where we use letters instead of numbers. You do this when you did the geometric formulas, right? A equals L times W, right? Area equals N times width. So we have, the notation is that the x would be what's called the base of the exponent. And the n is the exponent or power or index. Okay? So if I have 3 to the 4th power, what is the base of that exponent? What if I have 3 to the 4th power, what's the base?
3.
3. And what's the exponent?
4.
The 4. Right? So the base and the exponent. Okay? So base doesn't always mean an algebraic term, right? Have you heard the word base before in English? You bet. Have you ever heard of baseball or softball?
Yeah.
Yeah? So you see, base. So don't get caught up on the word base just meaning a letter, the variable in there. Okay? Now be careful here though. Look at this one. Okay? This one, the base of this exponent is actually the bracket. The base is what the exponent touches.
What happens if there's no exponent? The base is just the number.
Well, then you don't have to really worry about it because you're not worried about exponents then. So, what is this 3 actually right next to?
Bracket.
The bracket. So that means you're taking the entire bracket times itself 3 times.
So x, y, x, y, x, y.
Okay? So you must be careful about what the base is so you'll know what to multiply together. Okay? Now,
Well, bracket is whatever.
and then if you do the multiplication, x times x times x is x to the third power. And y times y times y is y to the third. So do you see having it there is the same, ends up being the same as just raising everything inside to the same power.
Yeah.
But you need to see that the base is the thing that it's touching. Okay? And there they have it worked out for you. Okay? All right. So I'm going to put this assignment, actually it's already assigned for you. If you've already done it when we assigned it before, then you do not have to do it again, although you might want to look at a few of them just to make sure you're back on track. If you did not do it before, then you need to get it done.